Hello, hello. Welcome back for Chapter 4, Lesson 1. This chapter, for this lesson, we're talking about congruence and transformation. Now, transformation should be a word that you recognize from Chapter 1. Remember transformations? We talked about 3 different types of transformations. We talked about translations. Remember, that was a shift, either vertically or horizontally, or both. What else did we talk about? We talked about reflections, right? And something that's reflected would be something like that, right? Or if it was here, an image that would be reflected would just be, oh goodness, now I can't pick it up. Hold on. If it was like this, a reflection would be like that. Or if you had something that was rotated around a point and it was, rotated around that point, then that would be a rotation. So we are going to be talking about congruence with transformations. So to get started, let's work on this warm-up. A figure has vertices A, B, and C. After a transformation, the image of the figure has vertices A prime, B prime, and C prime. Draw the pre-image and the image on graph paper here. Then identify the transformation. So I want you to go ahead and work out number 1 and number 2. And here's my friend the pause dragon. Remind you to pause your device. Go ahead and work out those 2 problems. When you get done, press play and we'll talk about them. All right, see you in a bit. All right, let's see how you did. So we're going to go ahead and plot these points. A is -3, 1. B is -1, 1. A, B, and C is -3, 1, 2, 3, 4. 1, 2, 3, 4. And that is C. I'm just going to go ahead and connect these dots. Like so. Perfect. And then we will graph the other image here. So A prime is 3, 1, 1, 2, 3, 1. A prime, 5, 1, 1, 2, 3, 4, 5, 1. This is B prime. And then C is 3, 1, 2, 3, 4. 1, 2, 3, 4. Did I plot these correctly? -3, 1, 2, 3. Oh, that's the problem. This one is supposed to be right here. I was like, this figure does not look correct. So it's supposed to be like this. And where is my friend? Correction tape. Yes. There we go. All that just goes away. Like so, kind of. Okay, now this is A. I was like, that figure doesn't look like anything like the thing I'm drawing. And then this is C prime. Okay, then we connect the dots here. And okay, so we plotted, this is A prime, B prime. So we start here, and this figure changes and it shifts over here. So that is called a translation. So if you said translation, great job. And it's a translation of how many units? So 1, 2, 3, 4, 5, 6. So a translation of 6 units we went to the right. So you want to have all that information. Okay, let's go ahead and look at the next one here. What do we have? We start with 2, 1, 2, 1. That's A. B is 5, 1. 1, 2, 3, 4, 5, 1. B and C is 4, 3. 1, 2, 3, 4, up 3. 1, 2, 3. Okay. And then that is going to transform into 2, -1, that's A prime, B, 5, -1, B prime, and C prime is -4, 1, 2, 3, 4, down 3, 1, 2, 3. This is C prime. And if we make that figure, this looks like a reflection, right? It's being reflected over the x-axis. So a reflection across the x-axis. So if you got that one right, great job. All right, so we are going to add one transformation. So we've talked to previously about translations, right, a shift. We've talked about reflection, something that's being reflected. We've talked about rotations, and now we're going to talk about dilations. So dilation with a scale factor k is greater than 0. Okay, that means k has to be bigger than 0. And center, 0, 0, the origin. Map, so this is kind of like the little rule, any point xy to kx, ky. So they're multiplying the x part by a number, and they're multiplying the y part by that same number. So you're starting here with xy. You multiply both the x and the y by the same number, and then that just, it dilates, it gets longer. So if the section was only like this big, now it stretches, and now it's that big. That's a dilation. Like your eyes, right? Your eyes are this, and then they, like the pupil, and then they dilate. It's the same concept. So remember, in a transformation, the original figure is the preimage, and the resulting figure is the image. Okay, perfect. All right, let's look at a few examples here with example 1. So example 1 states, we are going to be drawing and identifying transformations. Apply the transformation M to the polygon with the given vertices. Identify and describe the transformation. So here what we have is we have this particular transformation, right? We have P, Q, and R. And what's happening is we're taking each one of these vertices and we are plugging it into this formula. So P, that x value, you're going x minus 4, right? Which would be 1 minus 4 would give us -3. Okay, so we're starting here at P, 1, 3. And then, 1 minus 4 is -3. And then 3, this is the y value. You plug it in there. 3 plus 1 is 4. So that's how you get this -3, 4 P prime value. Okay? You do the same thing for Q. You plug Q, where Q is right here, and we plug it in. And then we get Q prime. Then we have R here, which is here. We plug it into the formula. And we get R prime right here. So what is happening right here? Is this a translation, a reflection, a rotation, or a dilation? And if you see, we're starting here and the figure just shifts over. So this is a translation. And what's happening? We're here and we're moving over 1, 2, 3, 4. I'm looking at Q and I'm figuring out where is Q prime. So 1, 2, 3, 4. So 4 units to the left. And Q is here, but then Q prime, it moves up 1. And 1 unit up. So that is the transformation. Okay, let's look at this next one. So here we have these 3 points, A, B, C. They're graphed here, 1, A, B, C. And then this is the rule that we're going to do to figure out the A prime, B prime, C prime. Now the figures are here, but I want you to understand what's going on. So we have A, which is 1, 2, that's our X and our Y, and then the X stays the same. So here on the A value, that's 1, and the A prime is 1, but the 2, when you plug that in, the 2 becomes negative, so the Y value becomes negative. So up here, A was 2, and then it becomes negative, so it's -2 down there. So it's here, and now it's here. And then the same is true. B is here, you put it into that rule, and then you get B prime. C is here, and then you put it into this rule, and you get C prime here. So what is this? What is this called? If you're thinking that this is a reflection, you would be correct. A is reflected. It's the same distance away. So from this x-axis is 1, 2 units away, and A prime is 1, 2 units away. C from the x-axis is 1 unit away, and C prime is 1 unit away. B is 1, 2 units away, and B prime is also 1, 2 units away. So it's being reflected across the x-axis. Okay, and then this last one here, well, no, it's not. C, we have points R, this is our pre-image, R, E, C, and T, and then we put it into this formula. X, Y goes to the Y and the X seem to switch places, and then the X becomes negative. And so for R, that's the X value. We put that in, it goes over there. So that would mean that R prime would be a negative X. So this is negative 3, so it would be a negative 3X, which would make it, a 3, which would make it positive. And then the Y value goes in front. So R prime would become 0, 3. And you can see that right here. So R was here, and now it's here. E, you do the same thing, right? So E, the X value is negative 3. You stick it in there, and then the negative and the negative become positive. So it's positive 3, and then this Y value just goes to the front. So E is over here, and then E prime, 3, 3 would be right here. So what's happening? You know, what looks like, and that's the same thing with C and T. What does it look like is happening here? And one thing I like about R, when we started with R, it's right here on that x-axis. And so if you see from R to R prime, it looks like it's being rotated, and it's nice because you can tell that that's 90 degrees. Let's look at E at being negative 3 and draw a line through this here. We'll look at the blue, right? And then look at E prime. Drawing a line to the origin, and you can see there is another 90-degree angle. So this clearly looks like it's a rotation. So it is we're starting here. This is a rotation. And which direction is it going? Is it going, you know, clockwise, or is it going counterclockwise? And it looks like since we're starting here and then we're moving over here, it's going counterclockwise. So it's a, I would say a 90 degree rotation counterclockwise. Counterclockwise. With the center of the rotation (0, 0). So we have the angle that it's being rotated. We've had the fact that it's a rotation. We have the angle that it's rotating. We have the direction, it's counterclockwise, and we have what it's rotating around, which is the origin. Okay, great. Let's look at the next one here, D. So we have D, and these 3 points, negative, and here's the rule, x, y, and it transforms to 3 times x and 3 times y. Does this look familiar? These values are plotted, k, l, and n, and then what happens? We apply this transformation. So k prime ends up being negative 2 times, negative 2 times 3, which is negative 6. And the y is negative 1 times 3, which is negative 3. So our k was here, and now our k prime ends up being negative 6, negative 3. And then the same thing is for L, right? You put that in. 1 times 3 is 3, so L prime is 3. And then negative 1 in for y, we get negative 3. That's what L prime is, so L's here, and then it's here. And then the same thing for N. So what does this look like? It looks like we're starting with a figure, and then that figure is getting bigger, and it's dilating. So this is actually a dilation with the scale factor, and I always like this, the number right there, that's the scale factor, and it just tells you. That's just how many times it's getting bigger. So here, we're starting with this, and then that tells us that this figure is getting 3 times bigger and turning into this figure. And it's the dilation of scale factor 3 with the center 0, 0. And it's always nice to see that center. If you line up the 2 lines, the points, so here's K and K prime. Okay, so if you line them up and you draw a line through them, and then I line up L and L prime, and then N and N prime here. What happens is the point where all 3 of those lines meet, that is your center. So for the longest time, I could never tell when I looked at something what the center was, and then I kind of did that trick where I run a line and then where they meet, and I was like, oh, that makes sense. That's why they say the center is that particular point. Okay, let's move on to check it out, example 1. Okay, so for this one, it says apply the transformation M, which is to xy, transform to 3x times 3y to the polygon with the vertices D, 1, 3, E, 1, negative 2, and F, 3, 0. Name the coordinates of the image points and identify and describe the transformation. So this one right here, we can go ahead and find those image points. Remember, we're going to take our rule and write it here. So here's the transformation. This is the rule. And can you tell what this rule looks like? Yes, this rule, it looks like the dilation, right? And this tells us. So we know we're going to be dealing with a dilation with a scale factor of 3, right? So but we need to find the image points. So we're going to take D. Whoops. We're taking D first, not D prime. D is 1, 3. And then we're going to transform that into D prime, which is going to be, this is our X, right? So 3 times 1, and then this is our Y. 3 times 3, and that equals D prime equals 3 times 1 is 3, and 3 times 3 is 9. Okay, and then we're going to do the same thing for E, is 1, negative 2, and we're going to transform that into E prime by going 1, sticking this X in here, so 3 times 1, and negative 2, so 3 times negative 2 equals E prime, which is 3 times 1 is 3. 3 times negative 2 is negative 6. And then lastly, there's F. 3, 0, which transforms into F prime. Would be 3 times 3 and 3 times 0, which ends up being F prime 9, 0. And then we know from this formula that this is a dilation with scale factor of 3. So there you have it. Well, I guess these are just our answers right there. Perfect. Okay, that's it for example 1. I'll see you in a little bit for example 2.